Hey guys, it's Sai Satvik here from Modern Education. Today we will discuss about free fall. So what exactly and basically is free fall? An object moving in such a way that its acceleration as well as its direction is downwards, and acceleration is only acceleration due to gravity, right? So its acceleration is only due to gravity and its direction is always downwards. So now free fall, to solve problems of free fall is little difficult actually. But if you follow my three procedures, it will be very simple. So the first procedure is that identify the values of the quantities, physical of the quantities given in that question, and then find the best equation for the values which you have find it out, and then equate with the given equation, and then your answer is done. Right? So let us discuss two cases here to derive or to get the formulas for few quantities. So the first case is, an object being held here. So you can take an example for free fall. It falls to the towards ground. So if the object is released and it falls towards the ground, what would its initial velocity be? So before falling, it would be at rest, am I right? So initial velocity would be 0. Let us write the given data as per the first procedure. So initial velocity is 0. Now what would be the final velocity? We don't know the final velocity at which it strikes the ground. We need to find it out. So the distance between the object when it is released, that point, and ground is given as height h. So the displacement would be height h. You can say just symbol of h max. Okay, so you can write it as displacement is h max, and the time taken also we don't know. We need to find the time taken. And one more thing is the acceleration. Remember I said that acceleration is only due to gravity, so it is minus g. Right? Assuming that in downward direction, even for height also, it would be minus h. So as displacement is minus h, acceleration is also minus g, initial velocity is u. Now you find the first procedure is find all the values of the quantities. So the second one is find the best equation of motion. What equation of motion would you use in this case? So I would prefer to find out time. You can use s equal to ut plus half at square, which is the second equation of motion, right? S equal to ut plus half at square, where s is minus h, ut 0 times t would give you 0, so half at square would give you half into minus g. We took acceleration is due to gravity, so minus minus symbol cancel, times t square. We need to find t square. Now t square would give you, if this thing goes this side, it would give you 2h by g, and if this 2 goes on the other side, it would give you root 2h by g. So t is equal to root 2h by g. So the time taken for a body in free fall to reach the ground would give you root 2h by g. Now let us try to find out the velocity. You can find the velocity using first equation of motion, because we have initial velocity, acceleration as well as time, or you can use this third equation of motion, v square minus u square by 2s. So let's try with the third equation of motion. U square would give you 0, so v square is equal to 2as, 2 times minus g times minus h, minus minus gets cancelled, so v, if the power goes on the other side, would give you root 2gh. So this is the formula to find velocity at which an object strikes the ground if it is released from a certain height h away from the ground, right? The velocity would give you root 2gh. So I'm sure that you understood the first case very well. So we found out the time and velocity for a free fall body, right? It's not for the body which it is thrown upwards. We are discussing about free fall. In case 2, we'll even discuss about an object moving in upward direction. So that's all for case 1. Now let's move on to the case 2. Okay, let's move on to the next case. Case 2. So the first one, let us think of upward direction of a body, right? So let's say this is the ground. From here, it is moving in upward direction till a point H. Not a point H, the distance is H. It is moving in upward direction. So if it moves in upward direction, it may not be in rest before. So the initial velocity, we don't know. But the final velocity can be 0, because after it attains its maximum height, it would gain a velocity of 0. So final velocity can be termed as 0. So in this case, we need to find out time, right? Time of ascent. What is time of ascent? Time of ascent. So we've already made a video on time of ascent and time of descent. So let me just give you a brief introduction on it. So time of ascent means the time taken for a body if it is thrown up with a certain velocity. That time to reach its maximum height would be the time of ascent. And similarly, time of descent, if a object is released from a certain height h away the ground, and to reach the ground, that time interval would be the time of descent. Now let's try to find out the time of ascent. So we've only discussed about the free fall cases. Now we are discussing about the second case, when the body is thrown in upward direction. So in the second case, we need to find out time. So first let us write down all the values. V is equal to 0, S is equal to minus h. So okay, here we are not assuming this h, right? Even we need to find out h also. So we know acceleration would give you minus g. Okay, so we can use the first equation of motion, which is v equal to u plus at, right? V equal to u plus at. So v would give you 0. So if my u goes this side, it would be minus u equal to minus gt. So here minus minus gets cancelled, and time of ascent, remember time of ascent, would give you u by g. So time of ascent would give you u by g. Now let us try to find out the height. So height or h max. H max. Okay. So height. So what equation would you use for height? You can take v square minus u square equal to 2as. Do we have v value? Yes. A value v square. So v value we have 0. U value we don't have it. What and all values we have? We have time. It is u by g. V, t, and even acceleration value minus g. V is equal to u plus we can't use that because there's no s. And if you see about second equation of motion, s equal to ut plus half at square. Yes, let us try using second equation of motion. So h here would give you ut plus half at square, whereas ut, so ut we are yet to find, u into t plus half at square of minus g square. Okay. No. If you use second equation of motion, you won't get the because there's time square, right? So mostly you won't get the value for second equation of motion. So we can't use the second equation of motion. So we are left out with the third equation of motion, v square minus u square equal to 2as. Then we'll get the answer in, let us check out. So v square is 0, so minus u square would give you 2 minus g times my h. This is the one we need to find out. Minus minus cancel. So here we get the answer as h is equal to, or before that we can simplify u first. U equal to root 2 gh, So here h is equal to u square by 2g. Right? So h would equal to, let's take this 2g as 1, and when this goes this side, it would be the denominator. So h would give you u square by 2g. So if a body moves in the upward direction, it would give you the height would be u square by 2g. So even if it moves in downward direction, the height wouldn't change. It would remain as the same u square by 2g, and time of ascent is u by g. Now let us see the remaining other one in case 2 itself. So we'll see the downward direction now. In that we'll even discuss time of descent. Okay. Now let's see the downward direction again, but this is in detail. So it is moving in downward direction, and u would be 0 as we have already discussed. V would be root 2 gh, right? We have already discussed. Now let us try to simplify these things. And at height, I think we don't know. We need to find out the height. So as well as we even know the acceleration. So u is equal to 0 here. V we don't, okay, just say root 2 gh, as well as acceleration same minus g. H we need to find out. So let us try to find the time of descent. Time of descent. Time of descent. Already told you what is time of descent. Time taken for a body from a certain height h. It needs to go to the ground. That time interval would be time of descent. So we can use the first equation of motion, v equal to u plus at. We don't know the value of v here. Suppose if assume that we are using first equation of motion, we don't know the value of v. We know the value of u. A also we don't know, so we can't use the, because we don't know two values, so it's eliminated. So second equation, if you use s equal to ut plus half at square, don't know. So time of descent, as we have already used the s equal to ut plus half at square, we can get root 2 h by g, right? So you must use s equal to ut, s equal to ut plus half at square. So this is the correct formula. Already we have used and got root 2 h by g. If we want to simplify it, 2 into, what is h here? U square by 2g. In the denominator 1 by g, right? 2 gets cancelled, so the result would give you u square by g square whole square root. Now we can simplify as u by g whole square, where square and root gets cancelled, so u by g. So time of descent is also u by g. Surprising, right? Because time of ascent is also u by g. So for a certain body, if it's thrown up with a certain velocity, and to reach its maximum height, it would take a time u by g. And from that point to reach the ground, it would again take u by g. So the time taken for a body to reach its maximum height. So when it is thrown up, it takes let's say time x, and again when it falls down, it takes the same time x. So time of descent, remember the formula u by g. Or if they give height, then the formula would give you root 2 h by g. In terms of height, you need to follow that. Now let us find out the velocity at which it strikes the ground, right? Velocity at which it strikes the ground. Let us say it as v dash. Okay, already we know v dash is root 2 gh, and we know the value of h, u square by 2g, u square by 2g. So 2g gets cancelled, and u square upon root, the square and root gets cancelled, so the value would give you u. So velocity at which it hits the ground would equal to the initial velocity at which it is thrown. So v dash, the result is u. So if a body is thrown with a certain velocity, it returns the ground and hits the ground with the same velocity, right? A body is thrown with let's assume if it is thrown with a velocity of 10 meter per second, it returns the ground also with 10 meter per second, right? So I'm sure that you have understood both the cases very clearly. Right, so let's end up the session. So I'm all sure that you learned everything. So remember that free fall, its acceleration is only due to gravity. In free fall, acceleration is only due to gravity, and its direction is downwards, right? Its direction is always downwards for a free fall body. So thanks for watching the video, and that's all for today. And more videos I'll be teaching you how to solve the problems related free fall. So I know you understood the basic concepts and how to derive these formulas. So we've learned many different formulas for each different case. So thank you for watching our video. If you like it, please do subscribe.